Okay, we'll go ahead and get started. Hello, everyone, and welcome to today's webinar on alternative water treatment for cooling towers, GSA water conservation guidance. I'm Andrea Silvestri with GSA Center for Emerging Building Technologies in the Green Proving Ground. And before we get started, I'm going to run through just a few webinar logistics. A quick rundown of the agenda. Today, we'll have a short introduction to the opportunity for alternative water treatment from Cedar Blasek, the Program Manager for GSA's Pilot to Portfolio. Then we'll hear from David Sickinger from the National Renewable Energy Laboratory, our subject matter expert and author of the guidance document. And he'll give you a high-level overview of some of the guide's content. And next we'll get some on-the-ground feedback from GSA staff Tyler Cooper and Jacob Lewis. And we'll have a Q&A at the end. So today's webinar, you all are in listen-only mode, and you can submit questions by using the Q&A button at the bottom of your screen. And you don't need to wait until the end of the presentations to submit your questions. In fact, we encourage you to submit your questions well in advance of the Q&A session. Today's webinar is being recorded and will be shared, and you can find presentation slides and recordings of all webinars on our webinar page at gsa.gov/CEBT. And you can also access all webinar recordings on our YouTube channel. The slides will be posted later today, and the recording will be posted next week. And the guide is published on gsa.gov, and you can find the complete guide there. And with that, let me turn it over to Cedar. Welcome, everyone.
So much, Andrea. Hi, everyone. For those of you I haven't met, my name is Cedar Blasek. I'm a program manager, and I co-manage our Pilot to Portfolio program here at GSA Center for Emerging Building Technologies. With my co-manager, Christiane Eady, we are laser focused on trying to figure out the best strategies and opportunities to widely deploy proven green proving ground and applied innovation learning lab technologies through reports such as the one you're going to learn about on today's webinar. Next slide. So why did we publish this report? Why do we care? GSA owns over 1,500 properties across the US, and 80% of that floor space is conditioned by chilled water plant cooling towers. That's roughly 1,000 cooling towers across our portfolio. So we have a lot of cooling towers, and we use a lot of water for our GSA facilities to make everyone comfortable in our buildings. Next slide. Why do we need to reduce our water consumption at GSA? Cooling tower water consumption represents, on average, 28% of the water use in commercial buildings. In the past 10 years, water rates have increased more than 40%, more rapidly than any other utility for GSA. In addition to the cost, water and wastewater systems generate greenhouse gas emissions during the sourcing, treatment, and distribution of water. So saving water helps us save and reduce our greenhouse gas emissions. And finally, federal buildings are subject to mandated water savings and reduction goals and requirements. GSA and NREL collaborated to release this guide for alternative water treatment for cooling towers. The guide is a result of the real-world evaluation of 6 different alternative water treatment systems in the GSA Green Proving Ground program. The document provides guidance on selecting, installing, and operating alternative water treatment systems in GSA facilities and beyond, and provides the basis for today's webinar. So with that, I'm going to hand things over to our next speaker and subject matter expert, David Sickinger from the National Renewable Energy Lab. David, over to you.
Thank you, Cedar. I'm David Sickinger, and I'm a researcher at NREL, located in Golden, Colorado. So since 2012 timeframe, I've been involved with the operation of the mechanical systems, including cooling towers that support NREL's high-performance computing data center. Various staff from NREL have been involved on these evaluations for the Green Proving Ground, responsible for the measurement and verification of the AWT systems and contributing towards this guide. So next slide, please. Just a brief background on cooling towers. They are an integral component of many refrigeration systems, providing comfort or process cooling across a range of applications. Open loop cooling towers reject waste heat to the atmosphere through evaporation. The operation for this consists of cascading water across the medium with resulting evaporation cooling the water, thus allowing heat to be effectively transferred to the atmosphere. However, as part of this process, minerals become concentrated in the water that remains, which can lead to accelerated scale or mineral deposits, corrosion problems, and biological growth. The typical approach to control these issues is a combination of chemical treatment and blowdown. Blowdown is discharging water to the sewer from the bottom of the cooling tower basin, and that can be as much as half in some cases. The simple graphic here is showing a cooling tower water inputs and outputs. So makeup water is introduced to dilute the remaining solids and replace water lost through evaporation and the blowdown process. The quantity of water evaporated is fixed. Approximately 1.8 gallons of water is evaporated for every 10-hour of cooling. So we're targeting savings from a reduction in water in the system blowdown. If you're not as familiar with cooling towers, the GSA website for this guide has an additional resources section with a link to a nice reference fact sheet that is titled Understanding Cooling Towers and How to Improve Water Efficiency. So next slide, please. So what are alternative water treatments, AWT systems doing? They're basically purifying the water somewhere within the cooling tower system to minimize the amount of blowdown water as reflected in this updated simple graphic. There are different approaches taken, but most AWT systems rely on proprietary technology offered by individual vendors. And as mentioned before, this guide has an appendix that provides a summary of the evaluated AWT technologies, along with links to past reports and presentations on each of them. Next slide, please. So 7 AWT systems were evaluated by GPG. 6 of these technologies proved successful and met the GSA cooling tower water standards, with makeup water savings ranging from 15 to 32%, resulting in paybacks in the 2 to 4 year time span when applying the GSA average water rate of $18.41 per 1,000 gallons at these testbed sites. These AWT systems aren't necessarily, though, set and forget systems, so operation and maintenance, O&M, planning is critical. Since most are proprietary, changes are required to O&M practices and contracts. Next slide. So maintaining an AWT system is critical for success, and these are sort of the 3 key takeaways that will be revisited throughout this webinar. First, want to ensure that local O&M teams are part of the decision-making process. They will be most familiar with the needs of associated cooling tower equipment. I also want to make sure that they receive adequate training on any new system. And we sort of found through these evaluations that that helps guarantee a successful outcome. Second, want to add, make sure the AWT system is added to the CMMS, the computerized maintenance management system. So O&M is maintained if contracts change. There's been a few cases where that's been an issue. So good takeaway, lesson learned. And then recent AWT project reinforced the importance of properly maintaining cooling tower systems, as that impacts both performance of the AWT and chemical water treatment systems. So suggestion is to consider including maintenance and energy savings performance contracts or by an authorized third-party water treatment company. Next slide, please. The questions shown in this flow chart can help determine if an AWT system will be cost-effective for your facility. If you answer yes to any of these questions, I recommend that you consider an AWT system now. If you answer no, might want to reevaluate in a year or if conditions change significantly. The 4 questions are, is the cost of combined water and sewer rate greater than $10 per 1,000 gallons? Do your cooling towers run more than 6 months out of a year? I mentioned our data center application where we have cooling towers that can run year round. So significant opportunity for water savings. Are you in an area that is risk for water shortages? And again, the report contains links to some nice water resilience resources, maps of the US showing water risk and monthly drought outlook. And then the 4th and final question is that we came up with is your site planning a major renovation or new construction? There's potential cost savings when combining this installation with other activities on your site. So those are sort of the things to keep in mind as we sort of progress through the rest of this presentation. Next slide, please. When selecting an AWT system, of course, you want to obtain estimates and choose the most cost-effective option for your location. City water quality used for makeup can impact performance. Locations with excessively hard water, high pH, or high total dissolved solids typically use more water treatment chemicals, and it will have the greatest opportunity for savings. Considering ongoing maintenance costs when selecting an AWT system, there are a few of these technologies that significantly reduce the amount of chemicals used, water treatment chemicals. Can look into whether or not service contracts are structured to realize these chemical savings. And then ensure the local O&M teams are part of the decision making. Again, sort of just reemphasizing that most of these systems rely on a proprietary technology offered by individual vendors. Next slide, please. So when evaluating systems, I want to consider energy, water, and chemical cost. Proposed system performance should result in a minimum of 15% water savings over current operation. And so part of going through this process is establishing a baseline that you can provide to the AWT vendors. Want to minimize maintenance costs, ask whether options exist, such as self-cleaning. Next three bullets are all sort of linked to guidance found in the GSA P100, the facility standards for the public building service. And in that document, it requires that a licensed water treatment specialist design the water treatment for cooling tower systems with consideration of the operational and maintenance need of all associated system equipment. So an AWT system must address these aspects, providing corrosion protection, controlling biological growth, inhibiting scaling, and meet environmental discharge regulations. And then on the last bullet on this slide is, AWT systems that are designed and sized to work for specific facilities in which they will be installed and be compatible with the rest of the system equipment. So then next slide. Mentioned before is that you do want to establish a solid baseline before an AWT system is installed. To sort of achieve that, I recommend a year's worth of records is ideal. However, meter data over a single cooling season is usually sufficient. When you are measuring water savings, you want to sort of do that over a minimum 3-week window of continuous operation, and then preferably track performance over an entire season, as conditions can kind of change over a season. Monitoring water quality monthly reports, including coupon stations to detect any changes, so it gives you time to correct if needed. The graphic on the right is showing sort of system inputs to the AWT, so that's makeup water, some that require energy, example, if additional pumps are required to operate, the O&M, and then the system outputs that are measured. So this is blow down, evaporation, and any material waste. And so this then is sort of used to determine the delivered results in terms of water quality, water savings, and cooling delivered. In the report section titled Measuring AWT Performance, there is a link to a nice guide on water meter best practices. So again, you can find that in the report. So next slide. So in terms of the measurements that are needed, so I suggest using this framework to establish the baseline and track your AWT performance. Sort of the required measurements that figure most into the verification of cooling tower water savings are blow down and makeup water consumption. Sort of the next thing to sort of track and meter is the water conductivity in both the makeup and blow down. And then during our evaluations, the status of water pumps and chillers were also recorded, so we knew which equipment was operating, along with supply and return temperatures. So when we did our load calculations, we had something to compare to as we looked at the ambient temperature and humidity for the test site. Next slide, please. So for those involved with cooling tower operation, likely familiar with cycles of concentration, or COC for short, it's sort of the most common metric used to represent water efficiency in cooling towers. It describes the mass relationship between the amount of makeup water and the amount of blowdown discharge to the drain. So high COCs are directly related to low levels of water loss from your system. GSA requires a COC value greater than 2. So at a COC of 3, around 33% of cooling tower water makeup is wasted as blowdown. So some of the AWT systems modify the conductivity set point to increase the COCs. Some are able to reduce water use without increasing the COC. Again, this is just sort of a metric. Kind of reviewing the different past reports and webinars will give you more insight into some of the approaches taken. But once you start increasing COCs beyond 10, as this graph sort of shows, there's diminishing water savings where blowdown starts to level off. So then there are 2 common ways of measuring COC. Sort of the first is the water balance approach, and that is where you take makeup consumption divided by blowdown consumption. And this is the recommended way to measure water savings before and after deployment of AWT systems to properly capture the net effects. The other approach is the COC by measuring conductivity of blowdown divided by makeup conductivity. And what we found, though, is with some of the AWT systems that treat water between the makeup input and the blowdown output stages, this method doesn't necessarily correct the capture the impact of the system. So next slide, please. So some things to the next 2 slides are actually going to cover a variety of things to consider when selecting an AWT system. Suggest asking for references, and ideally for systems of equivalent size that have been operating over a few cooling seasons. When you are selecting one, you do want to take into account the space, weight, and access conditions for your site. Asking yourself, will it fit through doors? One of the projects had to have a custom skid made to fit through a single door to reach the mechanical room. I want to consider if a crane is going to be required, or if you can get by with just installing through freight elevators. And will the floor support the wetted conditions if a reservoir tank is part of that system? If installed inside a mechanical room, it's also a good idea to have a sealed floor with drains. And then there's also sort of cybersecurity considerations, thinking about whether or not internet connectivity is required for the operation of the system. Service requirements and availability of local support is also something to keep in mind. And then the appropriateness of technology for local water chemistry, cooling tower equipment, and environmental conditions. So some localities have restrictions on salt-based water softening, for example. I think Texas only allows salt-based softening with proof of associated water savings. Sort of continuing on into the next slide, again, things to consider is whether or not the AWT system requires power, taking into account electricity rates then and accessible feeds in the location where you're going to install this, such as 120, 240, or 480 volt power feed. Piping to and from the cooling tower system can impact or be an expense. So location and proximity to the cooling tower system is key. Ask about available options. So some of these systems have like an auto cleaning mode that could potentially save significantly on O&M cost. Then you also want to consider system attributes such as flow rate, measured in gallons per minute, pressure, and predetermined water conductivity set points. Some sites are, we did find that existing operation, that was something they did not want to change, was a conductivity set point for a blowdown. And then ability for the site to meet AWT requirements, so analyzing the system. And GSA staff recommends that the manufacturer supply a checklist outlining the necessary system conditions, and then the design team should verify whether the existing conditions align with those requirements. There was an example where, at least one instance, we're not able to turn on the AWT system because of inadequate drain capacity, where system needed to discharge. So we'll go ahead and go on to the next slide. So INRAL used the whole building modeling software Energy Plus to model water savings potential for a large office building that was 500,000 square feet across the 16 ASHRAE climate zones. Those are labeled 1A through 8A. The life cycle cost effectiveness was calculating using a savings to investment ratio, where savings exceed investment when SIR is greater than 1. And in both of these figures, that's the horizontal line at the bottom. The SIR analysis assumes cycles of concentration move from 3 to 10, and that other annual operating costs remain the same. And then this was based on a 15-year project life. On the left side, what is being shown there is a $20,000 low-cost AWT system installed, and it's life cycle cost-effective across all 16 climate zones when the combined water and sewer rate is more than $4 per 1,000 gallons. On the right, that's just showing a $35,000 higher cost AWT system installed, and that's life cycle cost effectiveness again across all 16 ASHRAE zones when the combined water and sewer rate is more than $8 per 1,000 gallons. So water costs fluctuate widely across the country, resulting in more varied savings, but however, still cost effective. Next slide, please. So performance and savings are also site specific in terms of cooling tower performance. Incoming water quality can vary, such as hardness, total dissolved solids, alkalinity, conductivity, airborne particulate matter, and these all can have seasonal changes in those variables as well. And all this then sort of combines to impact cooling tower water treatment system strategies and effectiveness. In terms of water savings, sites in hot climates with long cooling seasons and long tower run times will typically have the largest water savings. And again, locations with excessively hard water, high pH, and high total dissolved solids typically operate at lower COCs and use more chemicals. So again, they have the greatest opportunity for savings. And then installing some of these are best practices and lessons learned when installing an AWT system. You'll want to install metering for the makeup water and blowdown water. Good time to consider replacing with new meters if you have existing hardware that is a few years old, so that you can have confidence in the data. Confirm as the system has been installed according to the design specifications provided by the vendor. GSA found several AWT installations with minimum water flow and drain capacity needs that were not initially met, which compromise sort of the overall system performance. Suggest working with the local water utility to capture any water rebates where available, and also incorporate water saving requirements into O&M contracts. Some other good practices is consider a side stream filtration system that has a backwash glass media system for open cooling towers. Again, towers are prone to collect dirt and debris. Along those lines too, a site recommended to consider a tower sweeper when installing a new cooling tower to deal with sediment that collects at the bottom of the basin. And it is good practice to try to integrate the AWT technology with a BMS, building management system, to help monitor performance. Do suggest that you try to initiate commissioning immediately after installation. Sometimes the timing with cooling seasons can make this challenging, but do want to, or your site should see proof of performance, and make sure that you receive the documentation, and make sure contractor fixes any outstanding issues. And then the last bullet there is AWT systems should not replace redundant systems. So in one GSA installation, a redundant cooling tower heat exchanger for process cooling was eliminated. And later on, they found that that created issues for the facility. So then kind of continuing the best practices, but in terms of maintaining an AWT system, really suggests that continue water monitoring after it's installed by a water treatment company, the AWT vendor or staff with specialized training. This all helps to provide early detection of potential issues and whether set points or operations need to be adjusted. Things can kind of change from cooling season to cooling season as perhaps the load changes. So again, having trained staff is key. Mentioned before, but we're stating again, just because this has sort of cropped up in some of the evaluations, is make sure to add equipment in a national computerized maintenance management system. And you want to include sort of maintenance in ESPCs as well, which will be discussed a bit more by GSA staff. And then consider having the vendor or an authorized third party maintain the AWT system. The systems evaluated in this GPG report were successfully operated during the evaluations, but once the vendor was no longer involved, a few of these systems stopped working as designed. So again, having that ongoing communication and cadence with the vendor is good to maintain. Making sure the teams, O&M teams, know how to operate the installed system, and making sure that requirements are transferred when and if contracts change. The reduced chemical cost, suggest trying to modify an O&M contract when applicable and possible to realize those savings. Things to keep in mind when you're selecting and a system. And then consider remote monitoring. This enables vendors to ensure their systems are working as designed. Again, having that ongoing dialogue with them. So I think up next then is going to be some on-the-ground feedback from GSA staff Tyler Cooper and Jacob Lewis. So I'll turn it over to them.
All right, yeah, thanks. Thanks, David. So yeah, I'm Tyler Cooper, mechanical engineer out of Region 8 here in Denver, Colorado. Based out of the Denver Federal Center. We've tested 3 of these cooling tower technologies and have done a widespread deployment for 2 of those technologies that we saw good success with. So we just want to focus on what we've learned as a region and what we see as best practices moving forward. So one of the things that we've noted throughout that's been consistent through this process is need for adequate cooling tower runtime. With our installations here in Denver, we have generally a 5-month cooling season, which still provides a good positive ROI for us. I think David noted that the average water cost nationally is about a little over $18 per 1,000 gallons. Here in Denver, we see that closer to about $7 per 1,000 gallons, and it's still seeing that ROI with these technologies. So as you're going through with site selection, knowing those daily hours of operations for the tower help you calculate savings. One of the good indicators is to performance is that cycles of concentration. Generally, if we're in around that 3 cycles of concentration or therein, we know there's a good opportunity for savings and improvement in those towers. And then one other note is when longer run times, just because you have, let's say, a 500-ton cooling tower system, we've compared that to a 1,500-ton system. And within that, the 500-ton system still had more savings due to the higher cycles of concentration it was able to achieve, coupled with longer run times overall. So it really depends on your site parameters as far as what savings are available and how much you'll achieve. Next slide. So in terms of maintenance, one of the things that, because we were early adopters with this, we did run into some maintenance difficulties. So within this, training with the O&Ms and incorporating that into the contracts was 2 of the main takeaways. Making sure the O&Ms know how to operate and maintain those alternative water treatment systems is critical. And then actually incorporating them into the contract requirements as a maintainable asset versus prescriptive water treatment parameters that you need to maintain with those cooling towers. So within that, specify within the O&M contracts how they maintaining those alternative water treatment assets as part of the contracts. And then within that, second, again, having some type of online reporting system to monitor results and O&M performance. We should be getting reports on a monthly basis and training your building teams, understanding what parameters they're looking for with those water treatment reports allows for that quality control check to make sure that those are operating optimally. Next slide. So in terms of lessons learned, making sure you have appropriate expertise from your water treatment vendors. One of the critical things is that water circulation in the tower basin, making sure that we're not getting algae blooms there. We have, whether it be water sweepers, anything's making sure that we're getting adequate flow through those tower basins is critical. If you have the opportunity, having a controller on site that either connects to the BAS and stores that data or is accessible for download, gives you real-time analysis of what that system is doing, and it's very helpful for troubleshooting. One of the technologies we did test, we did with a lease. So rather than buying the technology up front, just came with a monthly service fee with the vendor maintaining that technology and maintaining that alternative water treatment. So that's another option when we're not going with the capital expenditure up front. Within that, one of the ways that we can verify performance for these systems is with a boroscope inspection. Just measuring the scale that's within the systems before and after these alternative water treatment technologies are installed, and really helps to verify that performance and support the ROI on those technologies. And last piece, maintaining all your service reports. So being able to go back, look at performance over time, seeing how we're maintaining those, really just demonstrates the performance of these systems and how they should be operating. And with that, I will pass it over to Jacob for Region 9. I got one more slide too. And then last piece I wanted to focus on here, this is just from our alternative water treatment appendix. This is a sample of parameters that you'd be looking for when you're going out for solicitation for the alternative water treatment. Looking at age, number of cooling towers, what their capacity they're rated for, as well as the water quality parameters and operating parameters for that and the chillers. This really gives the water treatment vendors a picture of what type of technologies they need, how they need to size it, and how it would be applicable for the sites. With that, I'll pass it over to Jacob.
Hey, thanks, Tyler. So my name is Jacob Lewis. I'm the Senior Property Manager for the Nevada Field Office, located here in Las Vegas at the Federal Courthouse. My office was actually involved with 2 different AWT energy projects. The first one was back in 2019. We installed a water softening system that reduced the cycles of operation on our cooling towers. And the other project was a blowdown recovery system that was manufactured by the same manufacturer, and it tied directly into the water softening system, and that blowdown recovery recycled and reused the water from the towers. The actual installation for both systems was fairly easy. The physical installation for both of them were done over a weekend. With the water softening system, we had to do some hot taps and tie directly into the water systems in the chiller room, and it actually plugged directly into a wall outlet. Both systems were small in size that were able to just wheel right into the room using pallet jacks. And for the blowdown recovery system, the manufacturer came out, they did all the pipe connections. The only thing we had to worry about was actually running power to the system, which we had an adjacent electrical closet. So all in all, the installations were done over a weekend, and then the company had to come in and do some fine tuning, and they were on site for approximately a week for each installation. Next slide, please. As far as the day-to-day operations, you never want to say just plug and play and walk away, but with these, they kind of self-regulate and maintain themselves. We have had to alter our O&M contract a little bit just to make sure we're doing our daily checks, walking around the equipment, checking for leaks, alarms. With the water softening system, you have to add salt on a monthly basis. We have several systems that require salt, so we just keep a pallet of salt inside the room, and a couple times a month the mechanics have to check the salt levels and add salt. The blowdown recovery system does have an anti-skellet and a cleaning solution, so we had to monitor that. Since it's been in system, we've had to replace the anti-skellet barrel one time, and there is filters on the system that need to be replaced every few years. We've added this to our MCMMS system, and there is biannual PMs that automatically get generated that generally consist of calibrating the sensors, checking for system updates, and replacing like filters and stuff as needed. Next slide, please. So most of these things have already been mentioned in this presentation, so I'm just going to touch on a couple of them. I know David and Tyler both mentioned that you need to get your O&M involved early. You need to get all the players at the table right away. This was very beneficial to us during the planning phases, the installation phase, and the monitoring phases, to have our mechanics go to the meetings, having the chemical treatment guys go to the meetings, talk to the vendors, raise their concerns, and that really just created an atmosphere where they wanted to succeed. Their inputs mattered, and overall they helped to make the project successful. David had mentioned establishing a good baseline. We spent several months monitoring, checking levels, and we wanted to make sure we knew exactly how much water was being used, how much energy was being used. That way, after we installed the equipment, we're able to validate the success of the equipment. It's been mentioned several times that it's important to add this to some sort of maintenance record. Like we have an NCMMS where we track all of our inventory, we create PMs and work orders with this system. We made sure we added this equipment to that system right away. That way, PMs can be generated on a regular basis, and we can make sure that our equipment is being maintained properly. With that said, if you're choosing to do the maintenance in-house, you need to make sure that your mechanics and all the people doing the maintenance receive the proper training and have the proper tools. Like we had to buy some adapters and some software and stuff like that. So all this has to be pre-planned and make sure you execute it. And the last thing I really want to touch on is we've also changed our daily operations, where throughout our building, we have our mechanics check every mechanical space, every piece of equipment, chillers, boilers, all that. We made sure that was added to our daily checks, where our mechanics physically look at it every single day to make sure there aren't any alarms. We want to make sure that there aren't any leaks. We want to make sure the chemicals are being maintained. So your day-to-day operations do need to be altered a little bit. And with that, you also have to be able to monitor your other equipment. You have to make sure that what you're installing is not having a negative impact on the rest of your equipment, on your chillers, on your towers. In our case, there's been no impact, so it's been good. Next slide, please. Okay, that's all I have. I'm going to turn it back to Tyler.
All right, thank you, Jacob. So yes, and so in terms of alternative water treatment technologies, within all these, we're seeing water savings across the board. And if they're leveraged right, you can also see energy savings within that as well. So ESPCs provide a good delivery mechanism to go through and actually implement these technologies and capture those savings along the way. Within that, the effective water treatment reduces energy use in the cooling systems. Within that, if we are lowering the scale, we can see, we have seen increased performance in chillers as a result of that cleaner condensing water that's being sent to those chillers. So if you are able to measure that, that's an additional cost leverage that you can get within that ESPC contract. the benefit of the ESPCs is they can finance those upgrades for those water savings and no capital costs needed up front. One benefit of these projects is that they're generally low installation costs, but we will see very good paybacks over the course of them, which makes them great candidates for ESPC projects. And then just a holistic approach. So next slide. So in terms of integrating these into ESPC contracts, what we're looking at, one of the big things is determining who you want performing that operations and maintenance for these contracts. We can obviously have the ESCO perform that for the life of the contract or have the O&M contractor. So really looking at that from a cost benefit basis and managing your risk within that. Because these systems are often can be plug and play after tuning, identifying what additional O&M cost savings you have in there, and evaluating that over the life cycle of the contract to determine what those impacts are on your overall financials. Anything, as we mentioned with everyone else, anything that new equipment installed, make sure those are tracked in NCMS for those for the ESPC contracts and tied to that, as well as the O&M contract modification. So within that, the ESCO's responsibilities that we want to see, you want to ensure if they are maintaining those assets, ensure that they're trained for operations and maintenance and avoiding unnecessary equipment failures, because these cooling towers are often critical for the operation of our buildings. We want to make sure those are operating successfully year round. And then along with that, make sure they're getting their PMs and inspections completed according to the contract schedule, and make sure we're getting our energy savings achieved. So next slide. So in terms of reducing risk with our ESCOs, if within that, we typically require the ESCOs to provide a proposal for performing the maintenance on new equipment if it's atypical. So because some of these technologies can be different from what is a conventional practice, have them perform, one thing to consider, have them perform maintenance for at least the first 3 years of the contract. And then providing appropriate level of training on all the ECMs if they are included in that contract. Within that, one thing to consider would be getting extended warranties on that equipment, maybe a 3, 5, 10-year extended warranty, to ensure that those are operating correctly. And really what we're looking for is getting these options on the table so that we can go through as a customer and make the best design decision and figure out what system's going to be best and offer us the best lifecycle cost over the course of that installation. And with that, I believe that is the end of ours, and we'll kick it off to question and answer.
Great, thank you, Tyler, and thanks everyone for adding questions. And I think we have about almost 20 minutes, so if you have more questions, please add them to the Q&A panel. So with that, we'll jump right in. I think this first question is for you, David, and all the speakers, if you want to come back on screen and unmute. So how well do these AWT systems work to remove and prevent biofilm?
Sure. I mean, so some of these systems are working alongside standard chemical treatment, and then others take a different approach, but are including controllers to monitor water quality. So I think so the key takeaway is that still monthly water treatment reports are still required, along with ongoing monitoring to sort of track this so that things don't turn on you.
And do I remember correctly that all of the systems did meet GSA water quality standards?
They did. Good point.
And they were
yes.
able to control biofilm. And
they are.
Yeah, and Jacob or Tyler, you haven't had issues with biofilm in the systems that you have?
No, and I was going to kind of add, and I can only speak for my building and the technologies we used, but it had no impact, negative or positive. We used the existing water treatment plan that we already had in place, the same water treatment company and the same chemicals, everything that we already had in place. So I'd say in this particular case, nothing positive or negative, which is how we like it.
Great. And Tyler, in your region, any impact on biofilm?
No, and I would say that just goes back to these alternative water treatments function in cohesion with the existing cooling tower operations. So really want to make sure that you've got the water flow optimized in the towers, proper circulation, and if needed, getting the cooling tower sweepers in there to ensure that you don't have any stagnation of water.
Great. And we have a couple of questions now about Legionella, and both how effective were the AW systems at controlling Legionella, and are there any more at risk for Legionnaire's disease with these AWT systems? And again, maybe David, you want to start, and then Jacob and Tyler jump in.
Sure. Again, sort of just reemphasizing the last comment that, all these sort of met the GSA water treatment standards. And again, you're doing ongoing monitoring. Some of these systems are including an additional controller. And at least in one case, it was the additional controller that was added as part of the AWT system that detected some issues that were more related to the third-party water treatment vendor. And it happened to turn out then the next year that water treatment vendor was replaced. So they can provide you with additional insight into the water quality.
And Jacob and Tyler, any additional feedback, thoughts on the controlling Legionella growth?
No, I'd actually defer to the same answer I just gave. It's our water treatment didn't change with the installation of this equipment.
Great. Next question, does an AWT system prevent water stagnation compared to a traditional cooling tower? And David, do you want to start with that, answering that one?
Wasn't quite sure if this was sort of referring to, like if you have a cooling season, if you have like a startup process and sort of a turn down process, if that was sort of related. I don't know if, Jacob, if you had any thoughts with some of the systems you've installed, what you do sort of as the cooling season starts and ends.
No, I mean, there is some additional piping, but it's very minimal. So I would say no, there is not any increase in the stagnation.
Great. Let's see. Does anyone know if you're seeing an increase in water rebate availability for AWT systems? It sounds like we do. Go ahead, Tyler. Yeah.
I haven't seen an increase, but I think that, like, in terms of rebate availability, I think the critical thing to David's piece that he said earlier is making sure we have metering in place for the makeup and blowdown for those systems, so we can actually track the water savings, and then that's then applicable to applying for rebates with the utility.
Great. This is just a confirmation that, and I know you've all said this, but I think that it seems like a really important point, that water treatment is still a necessary step similar to a traditional system. So you're all continuing to work with a water treatment provider. Yes. There are a couple questions about looking for the vendors who provide AWT systems. So we can say that the guide that we're referencing in the appendix, the 6 AWT systems that were successfully evaluated at GSA are all included there, as well as, so there are links to the full reports, and there are also links to the vendors there. Let's see. One question was how frequently do any of these treatments use ozone? I think, David, if that's for you, I think the answer is no.
Right.
Yep. Okay. Have any of the AWT systems been tested on the East Coast or somewhere other than Denver, which may have higher humidity and can affect bacteria growth? And I do know that we have tested systems outside of Denver. I think we have one in Georgia. So that's going to be a place with higher humidity. Again, all of the testbed locations are described in the appendix of the guide, so you can get more information there.
Yeah, and then I'll just add, one of the technologies we tested at the DFC, they are actually based out of Florida. So their technology was rooted in humid climates.
Great. Someone notes as far as the water rebates that people have been receiving water rebates for alternative water treatment systems in California, Nevada, and Arizona. Again, a question about whether the vendors and manufacturers are listed, and yes, those are included again in the appendix in the guide, so you can get more information there.
Maybe just a additional point on that comment too is there is at least one case where GSA was testing sort of the first generation, and then the vendors based upon this testing and this program made enhancements and so forth. So as you do reach out, you might just want to ask them if anything has changed since, if you're referring to the report, and any enhancements that they might have made. I know at least one case to they sort of put like a battery backup on a controller and things like that can good lessons learned type thing. So
I'm not, Clifford, I might not understand this question, but the question was that they're using a lot of water for flushing due to Legionella testing. So it makes it hard to collect usage data until we can get consistent. I don't know if what you're looking for are thoughts on how to get, how better to collect water usage data in order to get a sense of how the system's working. And David, I don't know if you have thoughts on that.
Well, I know in the appendix there is sort of a section on if it's talking about metering and sort of best practices, maybe a place to start, I guess.
Great.
Not
Yeah,
sure the conditions that are kind of, go ahead.
I was going to add that hopefully this answers your question, but you should be installing meters on the actual piece of equipment that you're testing. So in our case, we actually installed like an additional 2-3 meters at various locations, one right outside the blowdown recovery, one going to the cooling tower itself. We had a meter on the actual blowdown. So we're not looking at just how much water is the building using, we're measuring that specific piece of equipment.
Great, thank you, Jacob. I don't think we have an answer across the portfolio, but Tyler, I know you've mentioned, the question is how many GSA-owned buildings have cooling towers with AWT systems? Again, I don't think we have that answer necessarily portfolio-wide, but Tyler, I know you've mentioned that you've been able to deploy a number of AWT systems. Do you have like an approximate number in your region that you've been able to deploy?
Yeah, I think for us, we've done about 20 to 30 buildings range is what I would estimate.
Great, thanks. Okay, I think with that, we'll wait for a couple other questions. I did want to say that there's a couple questions, and one of those was about continuing education credit. So we do offer continuing education credit through the American Institute of Architects. So if you're an AIA member, you can request credit. And if you're with GSA, we offer continuous learning points. And so all of those you can request. You'll receive, everyone attending will receive a survey, 5 questions to give us some thoughts on things that we can improve, or additional questions you have that we can answer about the technology and about the webinar. By completing that survey, you'll receive, be put on our list for receiving credits. And the other thing that I think, again, we'll say was discussed, what were the AWT systems evaluated? Again, these are in the appendix. So we have the blowdown recovery system from Aqualogics, a monitoring and partial softening system also from Aqualogics, chemical scale inhibition from Turlin, a salt-based ion exchange from WCTI. And then the 2 other systems were an electrochemical system from Dynamic Water Technologies and advanced oxidation from Clear Comfort. They were formerly Silver Bullet. So those were the 6 systems evaluated that proved successful during their testbed evaluations. Let's see. So for GSA contacts, you can reach out to Cedar, is it okay if we have, we'll have people reach out to you if we have questions, follow up for GSA?
Absolutely. You can reach out to me, but an easy email to remember is gpg@gsa.gov, and I do personally check that email. So if you have a question and you want to
Okay.
follow up after this webinar, the easiest way is gpg@gsa.gov.
And James, I see your question about costs associated with the installation of AWT systems. Again, the guide gives you more background on the installation, so you can get more details there. The purpose of this webinar is really to prevent more kind of overall guidance for how to approach AWT systems and really what to think about when selecting, installing, and maintaining them. And Valerie, the copy of the guide is on gsa.gov. I think we've dropped it in the chat, so you can access it there. So that guidance document is there, as well as the one-page infographic. And I think with that, if there are no further questions, we thank you. Thanks everyone for joining us today. Thanks for your great questions and for the presenters for being here. Again, follow up with any questions, and